Hello everyone. This video will be a short example of how to do an area and circumference story problem. Now, this is the same number 10 that is on the back of your area and circumference homework packet that I passed out on March 30th. So if you want to reference that in the future, feel free to. So let's take a look at this problem. Anna is covering the circular pool with a heavy-duty cover for the winter. The pool has a diameter of 24 feet. The cover extends 12 inches beyond the edge of the pool, and a rope runs along the edge of the cover to secure it in place. What is the area of the cover, and what is the length of the rope? So when we look at this problem, the first thing we should do is draw a picture to help us understand it. So we have a circular pool. Here's our pool. What do we know about it? We know that it has a diameter of 24 feet. Now remember that the diameter is the distance all the way across the circle. All right? So the diameter is the distance all the way across, and that is approximately 24 feet, just like this. We also know that this pool has a cover, and the cover is 12 inches beyond the edge of the pool. So let's go ahead and draw in our cover. The cover is in green, and you can imagine that because it's the cover, it is covering the pool, just like this. We know that it extends 12 inches beyond the edge of the pool, so we can extend it in our diagram like this. So take a look right here. I'm going to extend it by 12 inches. Now, I want you to be very careful. Make sure that you're reading the units and the dimensions that are used in the story problems carefully. In this case, you'll notice that this is in feet and this is in inches. So to make it easier on ourselves, let's go ahead and convert the inches into feet. 12 inches is approximately 1 foot. Actually, it's exactly 1 foot. So to make our diagram a little easier and have everything on the same page, we're going to erase this. Okay? We're going to get rid of our 12 inches. And we're going to call that 1 foot. I also want you to note that if we extend the line from the left-hand side, this on the left right here, this distance is also 1 foot. So now we have a long line, okay, that includes the diameter of the pool, which is 24 feet, and 1 foot on each side for the cover. We can redraw this as another circle. So let's try that. Let's move this over here. Let's move this circle. Let's move this circle over here and redraw it as one large circle. Well, not one large circle, but one combined circle. If we have 1 foot, 24 feet, and 1 foot, added up, we're going to have diameter of 26 feet for our combined circle. Now, with this, right, we are talking about our cover, because our cover covers the entire distance of the pool plus the parts that are outside of the pool. If we want to find the area of the cover, which is what it asks for here in the first question, we're going to go back and solve it like we did any other circle. So let me erase this, okay? Or actually, that's fine. We have 26 feet as our diameter. In order to use our equations, area equals pi r squared or area equals 2 pi r, we need r. So you'll remember that the diameter is 26 feet. So d equals 26 feet. The radius is half of that. So we have 26 feet divided by 2, which is 13 feet. That is our radius. Now that we have a radius, we can play with the equations. So I'm going to go ahead and erase this. We know that the radius is 13 feet. So let's write that up here. Radius equals 13 feet. I want to know what the area of the cover is. So the area equation for a circle is area equals pi r squared. We found r, so it's very easy to finish this off. Pi times 13 squared. Now 13 squared, I believe, is 169, but let's just make sure. 13 times 13 equals 169. So we have 169 pi. This is the exact number, okay? And I would be fine with this as a solution. But I want you to realize that in real life, people don't typically talk about things in terms of pi. We're not going to say, like, the cover is 169 pi in area. We usually use real units, okay? So we could say 169 pi feet squared for the area, but more realistically, we would approximate it as 169 pi, which is about, let's see, 169 times pi, 530.66 feet squared. I want you to keep in mind, I would like it if you could keep your answers, if you're approximating, out to 2 decimal points, out to the hundredths place, okay? So this is our answer. Either answer is correct. They are both the same. So for our first box up here, what we would have is 169 pi feet squared, or 530.66 feet squared. Let's go ahead and move on to the next part. So this, just to clarify, this right here is the answer that goes right here, okay? Either or. The next part of the question asks, what is the length of the rope? Okay, what is the length of the rope? So before I start to go over that, I just want to go tell you one thing. Imagine you have a rope, okay? Here's a rope. If that rope has a certain length, okay, let's call it L. And then we decided to manipulate that rope into different shapes. We could try to make a horse out of it. We could try to, make a circle, make a triangle. We could do a lot of things with this piece of rope, okay? Imagine if we took the two ends, here and here, and we turned it into a circle, like this. When you look at this, imagine that the two endpoints are on top of each other now, okay? Because we've turned it into a circle. The length around that circle is going to still be just as long as L. Because even though we've changed the shape, the amount of string is still the same, okay? So this is the circumference. It's the distance around the circle. The distance around the circle. So going back to our story problem, it says, what is the length of the rope? Now I want to give you one piece of advice here. If you're reading a story problem and it says length or distance around something, we're usually talking about circumference. If it's talking about amount or area or how much of something, we're typically talking about area. So those are your kind of hints for which equation you should be using, So in this case, we're talking about length or distance around. So we're talking about circumference. And the circumference equation is 2 pi r. Okay, we're done with area, so I'll get rid of this. So we have 2 pi r. If we plug in our 13 feet that we found earlier, we have 2 times pi times 13, which is going to be 26 pi. Once again, that's our exact answer. Our approximate answer would be 26 pi or 81.64. And it's going to be feet because we're talking about distance. We're not talking about area, okay? So it's going to be feet. So this circumference, either or, okay, they're both exactly the same. One is exact, one is approximate. This is going to be your solution for the second part, okay? And just to clarify as well, if you leave it as pi, you still have to have your units, okay? So don't forget the feet or the feet squared. If it's area, it's going to be squared. If it's circumference, it's not going to be squared. Make sure you include those in your answer. So this should give you some idea of how to solve story problems regarding circles, area, and circumference. I want to just put in one other statement and just inform you that you don't really want to memorize all the stuff in here, but just understand how it works. Every story problem is different. You will have to reason through it, okay? Every story problem is different. You'll have to think about it a little bit, but you'll still be using similar tools to solve them, okay? So I hope this was helpful. It'll be on the website if you need to look at it again. All right, thanks for watching and have a good day.